What's up everyone, Patrick here, welcome back. Moving on to the next question, still dealing with L'Hopital's rule. This is more of a word problem thinking question. So if f of x has a tangent of 8x plus 2y minus 10 equals 0 and an x-intercept at an x value of 2, then what is this limit over here? The limit as x approaches 2 of f of x all over e to the power of 3x minus e to the power of 6. So before getting into this limit, I kind of want to discuss the initial information that's been given about f of x. So we're told f of x has a tangent of this line here. Notice that this is a line, so if I take 8x plus 2y minus 10 equals 0, let's isolate for the y to put into y equals mx plus b form. So I'm going to divide everything by 2, and then we'll have 4x plus y minus 5 equals 0. And then, sorry, this 0 would get divided by 2 as well, which would just give us 0. And so if I isolate for that y, I get negative 4x plus 5. Right? So we don't know what the equation of the tangent is. We don't know what f of x is, but we do know it has this tangent right here at an x value of 2. We're also told that at that x value of 2, f of x has an x-intercept. So what we do know is that there's a point 2 and 0 on the function. Another way to write this is that f of 2 equals 0. So at this x value of 2, the y value is 0 for the function, and it has this tangent negative 4x plus 5. So if we show this visually, basically at this x value of 2, there's a y value of 0, it's an x-intercept, and we don't know how the function looks, we don't know what the function is, but because that slope of the tangent at that x value of 2 is negative, we do know that the function is going to be decreasing. Right? So when we draw a tangent here, let's say that's the tangent, the equation of this tangent is y equals negative 4x plus 5, like that. Okay, so just wanted to give you sort of a preliminary visual of what's happening with f of x before we even get into solving the limit. Sometimes students just have an issue figuring out what is happening with given information. So this is what's happening with f of x with the information that we're given. Now, let's go to this. We got the limit as x approaches 2 of f of x all over e to the power of 3x minus e to the power of 6. Now, first thing you always want to check, can you do a direct substitution? But notice if we do a direct substitution here, we'll have f of 2. We're pretty much going to plug in 2 for all the x values. 3 times 2 is e to the power 6 minus e to the power 6. And notice f of 2, we know it's equal to 0. And then notice this is going to be 0 as well. So if we do a direct substitution, it's going to be in this indeterminate form. But because it's in this form, we could apply L'Hopital's rule. So what we would do is we can rewrite this as the limit as x approaches 2. We take the derivative of the numerator. The derivative of f of x is just f prime x. The derivative of e to the power 3x is going to be 3 e to the power of 3x. And then the derivative of e to the power 6 is just 0. E to the power 6 is a constant. And now notice we could do a direct substitution because the limit as x approaches 2, if we plug in 2 for all the x's, we'll have f prime 2. And then down here we'll have 3 e to the power of 6. Now what's f prime 2 going to be? Well, it's the value of the derivative at an x value of 2. This is the slope of tangent when x equals 2. And notice we know what the slope of the tangent is. It's this negative 4 here. Right? When we took this and isolated, put it into y equals mx plus b form, slope of the tangent at an x value of 2 is negative 4. So we could plug in negative 4 here, and that ends up being your final answer. So with all that information given about f of x, we could figure out what this limit is, use L'Hopital's rule, and then that there is the final answer as an exact value.